All right, so this is problem number 11 on 5354. We're supposed to find the critical numbers and the max and min. So again, critical numbers occur where the first derivative is 0 or undefined. So I did the first derivative product rule. I did the first term, 2x squared times the derivative of the second, and natural log, whatever's after goes in the denominator, and the derivative of that denominator goes in the top. And then plus the second term times the derivative of 2x squared is 4x, and now I'm simplifying that right here. So what I need to do with this is I need to set this equal to 0 and solve it. So I'm going to factor out a 2x out of this thing right now. So when I factor out a 2x, I get this deal right here. So there's my equation so far. So hopefully everybody's okay with that. All right, so now I need to find, actually I should have probably done this and said f prime equals 0. Okay, so I probably should have done this. So then I'm going to get 2x equals 0, and I'm going to get 1 plus 2 natural log of x equals 0. So this says there's a critical number at 0, and then this would be there's a critical number if I subtract 1 and divide by 2, I get this. And then I have to e each side because natural log and e cancel out, so I get x equals e to the negative 1/2 power. Okay, so these are my critical numbers. These two things are my critical numbers. Well, we need to, well, let's just do this. So what I want to do now is find out where f prime is undefined. So what that's asking me, are there any values of x that I plug into here or up here into this that will not give me a value? Well, we got a little problem here because of natural log of x. So I don't know how many of you remember if you graph the graph of natural log of x, it looks like this. Okay, it looks like this, and the natural log of x has a vertical asymptote at 0, and it usually goes through 1, 0, and it goes something like this. This would be the number 1 where it crosses right here, the x value, and it goes down forever and never touches this. So because we have a natural log of x, x must be greater than 0 or you can't get a value. So this is actually not a critical number because x can't be 0. So f prime does not exist at 0 either. Okay, so really this is the only critical number that I need to worry about. Let's see, is this 5.2 or 5.3? This is 5.3, isn't it? Okay. So we need to do a number line with these critical numbers because, and again, this number line I'm going to make is not really, it is not really a part of the thing that the person grading this will look at. It is simply for us to make better decisions on what's going on. So I'm going to make my number line, and even though 0 is not a critical number, I'm still going to put 0 here because it can't be 0 because there is no such thing as a natural log. And then e to the negative 1/2 power is out here somewhere. Now what I need to realize is I need to find out what e to the negative 1/2 power, I kind of need to find out what that value is. Now this doesn't say I'm supposed to use a calculator. So what I probably need to know is this is 1 over e to the positive 1/2 power, which is actually 1 over the square root of e. And we may want to go ahead and write what this is, but something I don't know if you guys know is that e to the first power is like 2.718 ... That's Euler's number. This is a number used in nature. So if I put 2.718 in there, this is like the square root of 3. This is a little less than the square root of 3, right? Because 2.7. And it's bigger than the square root of 2, which is 1.414. Okay? So what I need to do is get a number between 0 and basically about 1 divided by that number. So it's less than 1/3 and greater than 1 over the square root of 2. So maybe, I don't know, maybe we should go ahead and put this in our calculator to see what this is, but it's going to be kind of tricky here because I'm not sure they would let you use a calculator, but I'm going to stick it in here just so that I know. And I'm putting this in my calculator right now. And it comes out to be about 0.6. It's about 0.606 on my calculator. So that means I need to pick a number between 0 and about 0.606. So I'm going to pick a half. I'm going to pick 0.5. Then I'm going to come over here and pick a number greater than this. I'm just going to pick 1. And I want to know what the signs are. Now, something I forgot to tell you maybe at the beginning is that whenever you're trying to find max mins, or whenever you're trying to find where a function's increasing, decreasing, you always want to use the first derivative. 5.3 was about increasing, decreasing. 5.4 is about max mins. They're put together because they're all about the first derivative stuff. So whenever you read something like that on a paper or test or quiz, I should be seeing the first derivative done. So anyway, I'm going to put 0.5, and I want to find out what kind of number this is going to be up here. Is it going to be a positive number, or is it going to be a negative number? Now, I could plug it in up here to this original thing, which I guess I can. If I do 0.5 times 2, that's a positive, right? And 0.5 times 4 is a positive. And if you look up here, 0.5 would be in this area, right? So 0.5 would be below. That's a negative. Okay, so I guess maybe we ought to do it here. So 0.5 times 2 makes this positive. 0.5 here makes this a negative. Now, again, the problem is we don't really know what the natural log of 0.5 is. So I'm going to see what the natural log of 0.5 is, because it's going to be a negative, and it's negative 0.69. And I've got to take that times 2. And that's negative 1.3. So you would have to use a calculator on this. So this is like negative 1.3 something. And the reason I need to know this is because if I add 1 to a negative 1.3, that makes this whole part negative. So a positive times a negative means this is a negative right here. So that is a negative. Now I'm going to plug in the number 1, which is easier math-wise. 1 times 2 is 1. The natural log of 1 is 0, so this 2 times 0 goes to 0, so this is 1. So positive times a positive is a positive. So what that tells me is this graph went from a negative to a positive. Okay, it went like that. So my negative, because this is the first derivative, and I should probably tell the world that I'm doing this, and maybe I should have put y prime because that's what they gave me. This is y prime, so I know that this graph is decreasing from 0 all the way to this e to the negative half, and then increasing. So this is a minimum. So what I need to do is figure out what this point is. So what I need to do is come up here and find out the y value, because this one's points. So I'm basically doing a t-chart where I'm plugging in an x and getting out my y, and I'm plugging in e to the negative half. Back up here for this, so I'm going to get 2 times e to the negative half squared times natural log of e to the negative half. So when I do this, this over here is going to be 2, and then you multiply these, so this is e to the negative 1, and then these 2 cancel out, so this is times negative a half. Okay, so that's not a negative. This 2 reduces with this 2. So this is negative e to the negative 1. So that means I have the point. The point is negative e to the negative half, that x with that y, negative e to the negative 1. That's the point that is my critical point. That's my relative max. So we would say f has I said max, it's a minimum because it goes down. I draw these on all my graphs and always look at them before I put max or min, because I know this is a min because of what these told me about increasing. This was decreasing to increasing. So you could write this down, but what I want you to know is you usually never find a point on these things. So the way you're going to write these on the AP test is you're going to say f has a minimum, and you don't have to use the word relative. F has a minimum at, and you use the y value, equals negative e to the negative 1, and then you say at x equals, and you use this. Now, if he says use a point, I will not count it wrong, but it is not the best way to write this. This is how you have to write it on the AP test. If you write down a point as a max or a min, you will miss that point. So we say f has a minimum at negative e to the negative 1. It's got to be the y value at x equals the x value. And that is because of the rules we have. F prime changes sign. And this is your reason. Now, he did not ask you to do this, but I want you to practice it. Changes sign from negative, because it was negative here, to positive, because it went to positive on this side, at x equals e to the negative half. This is how you have to answer these questions on the AP test. So that's how I would like you to do that. Okay? And the question I got asked is, even though it did not ask for points, do we still have to find the points? You need to find the x and y value, but I really want you to write like I just did. So please write it like that. Does anybody else have any problems they would like me to do? All right, we want to do number 4 on this same deal. So let me get number 4, a picture of it up here. Now this has to do with some trig stuff, so you need to know your trig, or maybe go back and study your trig some. And we're doing the exact same thing on this problem. So if you have a question on, as I'm doing this, please unmute yourself and ask it, because usually I'm looking at my screen and I cannot see. I don't really check the chat until I'm done. So if you get a question on this, let me know. So again, we got to find critical numbers. So I got to do the derivative of this thing. Have you noticed this has intervals 0 to 2 pi, but not including the endpoints? So the first thing I need to do is do my derivative. So the derivative of sine is cosine. And the derivative of cosine is negative sine x. Now, I hope you know that both of these functions are continuous forever. So what that tells me is f prime is never going to be undefined. So I get none from that. And where f prime equals 0 are my critical numbers. So that's where cosine minus sine x equals 0. So what I need to know is, where does cosine x equal sine x? Well, going back to the unit circle, there are 2 places. You're supposed to know that cosine represents the x value of the ordered pairs. And at this place right here, both the cosine and the sine, cosine is the x and sine is the y. They're equal here. And this is pi fourths. And then down here, both of them are negative radical 2 over 2. They're equal to each other again down here. And this is 5 pi fourths. So hopefully you know that. So that we get 2 critical numbers from this. We get pi fourths and 5 pi fourths. Now, because it says 0 to 2 pi, I don't have to keep going around and name all of them. I'm only worried about those 2. So these are my critical numbers. So then I'm going to do a number line. And I know I'm at 0 here and I'm at 2 pi out here because of this up here. I don't have to go any further than that. So I know one critical number is pi fourths. And I know another critical number out here is 5 pi fourths. And remember, we're checking out the derivative. This is a number line for the derivative values. So I need to find out what the signs are here, here, and here. So I'm going to plug in numbers between these into my derivative, into this thing. So I want to use numbers that we know. So I'm going to use this value right here, which is pi over 6. And this ordered pair is radical 3 over 2 and 1/2. Okay? So I know that the cosine is 1/2. And this, oops, I got that backwards. Cosine is radical 3 over 2. And sine is 1/2. Plugging in pi 6. So I'm plugging in pi 6. So I hope we know the square root of 3 is greater than 1. The square root of 1 is 1, so the square root of 3 is greater. So if I have a number greater than 1 minus 1, that's going to be a positive. So I know here is positive. So from 0 to pi 4, this function's increasing. Then I need to pick a number between these two. So that means on my unit circle, I want to pick a number somewhere between here around to here. Well, the quadrantals are my favorites because then I don't have fractions and radicals. So I'm going to pick pi over 2 right here because that's between those. So I put pi over 2 in. I know sine is 1 and cosine is 0. So if I take 0 minus 1, this makes this negative here because this is a negative value. And last, I got to pick a number between here and 2 pi in here somewhere. And again, quadrantals are the easiest, so I would pick 3 pi over 2 right here, which is 0, negative 1. You could pick any of these you want, but this is easier. So again, now this is 0 again, and then minus negative 1. That makes this positive 1. So this is a positive. So my function from 0 to pi over 4 is increasing, and then it decreases from pi over 4 to 5 pi over 4, and then increases after. So if you look, that tells me I'm increasing to pi over 4, and then I start decreasing. That means this is a max. And then I'm decreasing, and then on the other side I increase, so that means this part is a min. Okay? So I get to say F has a minimum equal to. Now I have to go up here to find my minimum. So I need to find what F of pi over 4 is. So that's going to be sine of pi fourths plus cosine of pi fourths. Well, what that equals is, right there's my pi 4 stuff, right? So that's radical 2 over 2 plus radical 2 over 2, which is 2 radical 2's over 2, which is simply radical 2. So I have this thing has a, oh, I put min. Again, I look up here, it's max, not min, so I screwed up. So that's another reason to draw it on there. I have a max equal to radical 2 at x equals pi fourths. And then I put because f prime changes sign. And again, he's not asking you to do this, but we want to practice it because this is what you're going to do on the AP test. Changes sign from positive to negative at x equals pi fourths. And then I come down here and I say f has a min equal to. So I need to find the min at 5 pi over 4. So now I'm going to subtract these two things. So I hope you see that that's just going to make this a negative and this a negative and make that a negative and that a negative. So I would say it has a min at negative radical 2 at x equals 5 pi over 4 because f prime changes sign. You can always look right up here. What did it change from? F prime changes sign from negative to positive, and you can use these symbols at x equals 5 pi over 4. Now that's a lot of work, but that's going to be worth probably 3 or 4 out of 9 points on an open-ended question. Okay, for number 4, aren't we looking? Oh, I didn't read the directions. Okay, I screwed up. Yes, we are. So I gave you the max and the mins, but that was not what I was supposed to do because I did not read the directions. So this would have been how to find the max and mins, but we use this same chart to find increasing, decreasing. So we would say F is increasing from 0 to pi fourths and 5 pi fourths to 2 pi because f prime is greater than 0 on those intervals. Thank you for getting me on that. And then we would say f is decreasing on pi force to 5 pi force because f prime is less than 0 on that interval. Okay, so that is actually what we should have done. So I did 5-3 and 5-4 on a problem that I was only supposed to do 5-3 on. My bad. Anybody else got anything you want to see? Could you do 13? I sure can. You want, okay, we'll say it's on the same one. All right, I gotta get a picture again, so hold on a second. And I better read the directions. So I'm going to do the exact same thing I've been doing, I think. Find the critical numbers, use first derivative test, find relative min and maxes, and I'm going to do the exact same thing that we did before. So I'm going to, first of all, I got to find my critical numbers by putting the derivative equal to 0. So we have to do that. This is, again, a product rule. So y prime is going to equal the first term times the derivative of the second term. So it's e to the negative x times the derivative of negative x, which is -1, plus the second term times derivative of the first term. So if I simplify this, I get negative, I'm going to put the positive part first. So I'm going to write this part first. So I get 2e to the negative x, and then this is negative 2x e to the negative x. So there's my derivative. Now we want to factor this. I want to find where f prime equals 0, and I want to find where f prime is undefined. Well, this function is continuous forever, so there's none. Okay, nothing from that part. So over here, I'm going to factor out a 2 and an e to the negative x because that's in common with both these common factors. So when I take it out of there, I have 1 minus x equals 0. So I want to find where 2e to the negative x equals 0 and where 1 minus x equals 0. Well, this one's pretty easy. This is x equals 1. Now we need to remind ourselves about what e to the x looks like. All exponential graphs look similar to this. They usually are above the x-axis. They go through 0, 1, and they take off. Okay? Now that negative in front, well, the 2 makes it go up twice as fast, which isn't really a big deal. That negative in front reflects it over the y-axis. So this actual graph looks like this. It looks like the exponent flipped over the y-axis. So it's actually the black part. So the question is, where will this black graph cross the x-axis? So it's important that you know this. There's nowhere. So I get none for this. It never equals 0. So my only critical number is 1. So I need to find out, do my number line. And if you notice, unlike the last one that said 0 to pi, there aren't any intervals. So this means we're going from negative infinity to infinity. So I've got to put my 1 here, and all I got to do is pick a number to the left, a number to the right, plug into these two things and see what I get. So if I take 0 and plug in here, I hope you see this is positive forever. So this part is positive no matter what. If I plug 0 in there, this part's positive, so the graph is positive here. And if I plug in any number to the right, let's say I plug in 2, it is still positive over here because this graph never crosses x. So this is still positive, but if I plug 2 here, this becomes negative, and a positive times a negative is a negative. So this graph goes from increasing to decreasing. So this is a max. Again, I'm getting increasing from the positive and decreasing from the negative. So I know what 1 is a max. Now I need to find that value. So I need to find y of 1, which is going to be 2 times 1 e to the negative 1, which is going to end up being 2 over e. There's my max. If you leave it 2e to the negative 1, that's fine. So we would say y has a max equal to 2 over e at x equals 1 because y prime changes sign. And when I get to this point, I always look and make sure I get the right answer. So I say from positive to negative at x equals 1. And there's my answer. Okay, anybody else need any? Please start turning in your stuff for my class into Canvas now. And again, I put the keys to all these up there, so if you have trouble, let me know. And again, my email is going to be out or down or not working or only working sometimes at home until tomorrow night. So please turn all the stuff in to Canvas. So I will see all of you tomorrow at the same time, and I think we're going to have a quiz. So have a great day and take care. See you.